In this module, we shall learn about the different types of marks that you find on the glass, that is the rib marks, the hackle marks and the backward fragmentation. Let us come to the introduction now. Glass, as you know, it is going to bend as a response to any force that is exerted on any one of its sides. But when the limit of elasticity is crossed, the glass will fracture. Frequently, most often, fractured window glasses will reveal the information which is related to the force and the direction of the impact of the projectile. Such knowledge may be very useful for reconstructing a crime scene which is under investigation. The penetration of any ordinary window glass by a projectile. That projectile may be a gunshot or it may be a pebble, but whatever may be the projectile, in this case the glass, the projectile is going to produce a familiar type of fracture pattern in which cracks both radiate outwards as well as they encircle the hole. Now the radiating lines are what we call as radial fractures, while the circular lines are termed as concentric fractures. Now, on a very close examination of fractured glass, different types of markings can be found, which actually tells us about the direction of the force and the stress with which the projectile has been shot on the glass. Now, depending on whether the hit is a direct hit, or in other words, you can say whether the force is perpendicular to the glass or whether the force is sideways, that is left to right or right to left. Different markings which are characteristic of a glass may be observed. This actually makes the first step in the examination of glass very simple. A person, as an example, who is standing very close to the glass, when the glass had been broken, then that person may pick up the fragments of the broken glass, maybe on his shoes or on his clothes. For example, the clothing, if you find, of a burglar. In cases in which the window glass has been broken, then those clothing will most often retain very small microscopic glass fragments. Also, as an example, you can consider hit and run cases in which the headlight lenses can be broken or other type of window glasses of the vehicles, they may be broken, and both actually the scene of the incidents, that is the scene of the accident, and the clothing items of the participants may have a lot of very small microscopic glass fragments, which when we examine can give a lot of information about the crime that has actually occurred. Now, there are different types of glass examinations. As an example, we can consider that the pieces of broken glass or sufficient size from a physical hit, that is a direct hit, thereby making a direct association, that is, for example, whether the glass is from a particular window or a door or something else. Now, the glass fragments of many sizes may be microscopic or macroscopic. They can be very well compared. This analysis actually gives us an indication of common origin, but probably this may not be an absolute identification. Now, it may also be possible to actually know the side of the impact to a window, or in other words, you can say the direction from which the projectile has been fired at the window. It may also be possible to determine the sequence of multiple fractures, such as the case which you can find in bullets. Now, if a glass object has been exposed to fire, it may be possible to determine if it has broken as a result of heat or by some other mechanical force.
Rib marks. When, on examination of the fractured edges, if curved markings like waves are observed, then these markings are called rib markings. The convexity of these marks actually indicates the direction of travel of the bullet. They appear perpendicular to the surface at which the crack is originated and then curve asymptotically, that is, meeting at infinity with the opposite surface. The direction of travel of the crack along the glass is from the concave side of the rib marks to the convex. The rib marks being almost at right angles to the face of the glass on which the crack has opened, it has been observed that on radial fractures the rib marks are perpendicular to the face opposite to which the force has been applied, while on the concentric fractures the rib marks are perpendicular to the face on which the force has been applied. The crack opens on the opposite face to the point of contact. The examination and thus the interpretation of these fractures are used to determine whether a window has been broken from inside or outside. Thus, it is necessary to determine as to which surface of the broken pieces of glass under consideration were originally interior or exterior. Rib marks are the most conspicuous of all the glass edge markings. Curved shell like marks. These are also called conchoidal marks or Wallner lines. Stress fracture lines known as conchoidal lines which radiate away from the impact size can help to make this determination. Viewed through the thickness of the glass, these lines tend to curve out and away from the point of impact. Looking more closely at these edges, conchoidal fractures, smaller lines that radiate in a perpendicular direction from edges that face away from the impact site may be seen. These are called hackle marks. If a projectile such as a bullet strikes a window and penetrates it, but does not completely shatter it, it may leave a hole with or without surrounding fracture lines. On the side of approach, the bullet creates a rather clean hole, while on the opposite side, a small cone-shaped plug of glass is forced out. Simple visual inspection of the impact site reveals the projectile's direction of travel. If multiple bullets or other projectile fracture the glass, it is often possible to determine the order in which they struck. Typically, the radial fractures caused by the second object do not cross those of the first. That is, they end when they encounter glass that is already fractured. These findings can be extremely important in corroborating or refuting suspect and witness statements and in reconstructing the events surrounding the crime. They can also be useful in assigning culpability. We know that a fracture propagates perpendicular to the principal tensile strength, due to which the fracture tend to orient themselves in such a way that they continuously remain perpendicular to the principal tensile stress. So, when examining a radial fracture, the conchoidal lines meet the opposite to the force at nearly right angles and then curve back asymptotically towards the side from which the force was applied, but in concentric fractures. The tension is on the surface facing the force. So, when the glass breaks due to tension failure, the fracture is initiated on the side facing the force. The curved rib marks or conchoidal marks will now meet the side, which is the side facing the force, at almost right angles. Radial fractures are also useful in determining the direction a pane of glass was struck from. Stress marks on the edges of the radial fractures conform in a specific way which will show the direction of impact. Stress marks are curved. One end of the curve runs parallel to the glass surface. The other end of the curve runs perpendicular to the glass. The side of the glass which has stress marks which are parallel to the surface is the side which sustained the impact. Very often, the glass in question is shattered and must be pieced back together. An investigator can start with the frame which is labeled as to which side is the inside and which is the outside. Loose pieces of glasses can be matched up, pieces still adhering to the frame. Once the pieces are all in place, the point of impact can be determined. The radial fractures can be examined to determine from which side the glass was broken. Determining the side from which glass was broken is important in burglaries and other crimes involving home invasion. Arson investigators have particularly interest in knowing whether a pane of glass was broken from the inside or outside. Windows broken from the inside at the top of a structure can indicate an attempt to ventilate the building. Ventilation causes the fire to spread upward following the source of oxygen. A fire started at the bottom of a structure can be made to race through a structure more rapidly than normal by ventilating the upper levels. The concentric fractures form on the glass side of the glass surface as the point of impact. When glass breaks, most of the glass falls inward. However, the tiny shards produced in the formation of the concentric fractures spray backwards towards the person wielding the weapon or tool. These tiny bits of glass can get caught in the hair and clothing of a person near the point of impact. Even after washing, tiny fragments of glass can remain caught in the fiber of clothing and footwear. When a gun is fired at a glass surface, tiny particles of glass can spray back up to 18 feet. Hackle markings. Hackle markings are found in that area on the fractured surface where there has been a relatively high stress. These markings actually consist of ridges running in the direction of fracture propagation and are at right angles to any rib markings which may be internal. They are most prevalent when the fractured surface runs at an angle of 45 degrees to a pre-existing free surface. Thus, hackle markings are a definitive indication of the direction of propagation. There are four types of hackle marks. Twist hackle. They appear at the region where the tensile stress twisted from cracked surface. Twist hackle can be generated by the primary crack as it travels through the body, especially as it goes around the corners or geometric irregularities or if the stress conditions change. Mist hackle. They appear around the origin. They are also called velocity hackles. Coarse hackle. Coarse hackle is also known as striations, which is a fracture surface markings consisting of a separation of the advancing crack front into separate fracture planes. Shark's teeth are striation markings consisting of dagger-like marks starting at the scored, that is, indented side of a glass plate prior to deliberate breakage thereof. Shear hackle. It is generated by shear component with the principal tension component under which the crack is running. It differs from twist hackle in that the force is perpendicular to the initial direction of crack propagation. Backward fragmentation. In 1967, Nelson and Revell reported the backward fragmentation of glass and demonstrated it by photography. Backward fragmentation is the scatter towards the direction of the force and has since become known as backscatter. They broke 90 sheets of glass and observed backward fragmentation in all cases. They observed that whenever a window is broken, it is to be expected that numerous fragments of glass will strike any person within a few feet of the window. If a glass breaks as a result of mechanical impact, then a large number of small glass particles will be generated and is projected for a considerable distance from breaking the object. The projection of glass particles back towards the person or object breaking a window is known as backward fragmentation. This is the actual means by which someone who is breaking a window acquires glass particles on his or her clothing. If a glass breaks under thermal shock, then it has an irregular pattern and produces far fewer small particles than an impact break. The size of the fragment that are likely to be transferred from crime scenes depends on the type of glass that was broken and many other factors that are discussed later. However, there are two types of crimes that have been reasonable chances of producing large fragments for comparison. These are an hit and run incidents where a vehicle has collided with another vehicle, pedestrian, or other objects, and ram raids incidents where a vehicle has been used to effect entry. In hit and run cases, broken tempered glass produces relatively large pieces, often scattered at or about the point of impact. These pieces usually include original surfaces. Full thickness measurements are also possible. Ram raids may result in large pieces of window glass being transferred to a vehicle. However, in the bulk of cases of glass breakage, glass transfer to clothing involves small fragments with their size ranging from zero point 0.1 to 2 mm and their shapes being typically irregular. In detail, whenever a sheet of glass is bent so that there is a tensile strain on one surface, there is actually a compressive strain on the other surface. When the glass breaks at the surface under tension, the crack travels to the surface under compression so that whole compressive force is exerted along the broken edges in contact. This causes flakes to be split off the broken edges of the glass sheet at the compressed surface, and these chips frequently fly off with considerable velocity. Chips from radial fractures come from the side of the glass to which the force was applied and travel in the direction opposite to the force.
Now, let us summarize as to what we have actually studied in this module in details. In this module, we have actually learned about the three major different types of markings that you can find on a glass, that is the rib marks, the hackle marks and the backward fragmentation, which are actually helpful in interpreting the direction of the impact and the strength of the force. Now, in determining the direction of force, only those pieces which are very close to the point of origin are actually suitable for interpretation. It is actually advisable not to select any type of glass piece which is very close to a frame, as the rigidity with which such a piece was held may influence the nature of the fracture feature, and this will also make the interpretation of the impact and the strength of the force quite difficult for the forensic people. Now, on the examination of fractured glass, different types of markings have been observed, which actually, as we have just now said, tells us about the direction of the force and the stress with which the projectile has been hit or fired on the glass. Now, if a glass object has been exposed to fire, it actually may be possible to determine if the fracture is because of huge amount of heat or due to some mechanical force. Simple visual interpretation of the impact will certainly reveal the projectile's direction of travel.